lesson 3 in chapter 4 is on functions. We've kind of already talked a little bit about whether something is a function or not, but in this lesson we're going to go a little bit further into what a function actually is. So let's look at your vocabulary startup. Okay? A function is a relation in which every member of the domain is paired with exactly one member of the range. And we've talked about that. Your x's, when we do a mapping, can only be paired with one y value. You can't have an x being linked to two different y values. That's when it's not a function. So in order for it to be a function, every member of the domain, which are your x's, is paired with exactly one member of your range, which are your y's. Okay? An example of a function is m equals 20. M represents the amount of money earned, and n represents the number of lawns mowed. So in this example, n is the independent variable, and m is the dependent variable. So when you think about that, the independent variable is always going to be along your x-axis. If you're going to graph this, your independent variable will always be on the x-axis. So in this one, your number of lawns would go along the x. Your dependent is always the y-axis, and that's going to be the money that you make. So right now, take a second and write down what you think the independent variable means and what a dependent variable is. I know that you've talked a little bit about this in science. Okay, so go ahead and write two definitions. Okay, go ahead and pause the video. Okay, let's take a look. Your independent variable is the variable that can change. Okay, you get to choose the values for that. 5 lawns, 20 lawns, 15 lawns, that's your choice. That's the one that you can change. Okay, the dependent variable is the one that's affected by the independent variable. So as you change the number of lawns, the money that you make changes. Okay? Let's look at some examples down here. What we want to do is we want to practice identifying the independent variable and the dependent variable. And again, something that might help you is, what would I put along the x-axis? If I was going to graph this, what would be along the x-axis? Because that's going to be your independent variable. Okay? So if we look at the first example, the equation is c equals 0.99n. Okay, and it represents the total cost, c, for n music downloads. The number of downloads is going to be your independent variable. Did you download 5, 6, 7? And your dependent is going to be the cost, because the cost depends on the number of downloads. Okay, the next one. The equation d equals 4.5h. Okay. The number of miles is d, and Amber can run in h hours. Okay, so in this case, the number of hours is going to be your independent variable, because you choose how many hours Amber's going to run. And then what that means is your number of miles is going to be the dependent variable, because the number of miles depends on the number of hours that she ran. Okay, in this equation, the equation s equals g plus 3 represents the final score of the game S after g goals in the final period. So in this problem, what depends on what? Does the score depend on how many goals? Yep. The final score depends on the number of goals. So the number of goals is what you choose. That would be along the x-axis. Up the y-axis then would be your final score, your dependent variable. Okay? All right, let's take a look. To find the value of a function for a certain number, substitute the number for the variable x. Okay, very easy to do. And again, remember the poster that's in my room? It says, function notation is just a fancy way of writing y. This f of x, that's how you say it, f of x, is the same thing as y. We could rewrite this y equals 15x. But we want to put it in function notation. Okay? So this is really your y, or your range. X is your domain. So if we have an example that says find f of negative 3 if f of x equals 2x plus 1. All they want you to do is to take this value right here, negative 3, and they want you to plug it in for x, right there. Okay? So it's going to look like this. Here's your variable, or here's your function. Okay, we're going to take whatever value they gave us, negative 3, and we're going to plug it in for x. Okay, so f of negative 3 equals 2 times negative 3 plus 1, and that's going to give us negative 5. So your value is negative 5. So basically it's another way of just saying if y is this, or if x is this, what is y? Okay, so we plugged in this negative 3 in for our x, and we simplify, we get negative 5. Alright, why don't you go ahead and pause the video and try these two practice problems. Okay, so if we look at the first one, here's your function. They want us to substitute 2 in for our x. So if x is 2, we're going to plug in a 2 here. 2 minus 4 is negative 2. So your value of this function, if x is 2, is negative 2. Okay, over here we're going to plug in 11 for x. Okay, so 1/2 times 11 plus 5 is 10.5. Okay, so again, it's just a different way of writing a substitution problem. Okay. All right, now let's look at function tables. All of these are input-output tables. We've done them before. Okay, you can organize the input, rule, and output into a function table. The variable for the domain is called the independent variable, or your x's, because it can be any number. The variable for the range is called the dependent variable, or your y's, because it depends on the domain. So let's take a look. Okay, it says choose 4 values for x to make a function table for f of x equals x plus 5. Then state the domain and range of the function. When it says choose 4 values of x, you get to choose your own. You can make them any value you want. I suggest you keep them smaller in size in case you have to graph it. Okay, so let's look at your function table here. Here are your x's, or your domain, your range, which are your y's. Okay, this is your x, this is your y, and your rule is your function, x plus 5. Okay, so look how they have this set up. X, y, or f of x, and here's your rule. So what they did, they chose, here are the values that they chose, right here. They chose negative 2, negative 1, 0, 1. And again, that's your choice. You can make them whatever you want. So what you do is you plug that into your rule, so you have negative 2 plus 5, negative 1 plus 5, 0 plus 5, 1 plus 5. And here are your corresponding y's. Okay, when you simplify them, negative 2 plus 5 is 3. So here, this is a function table. Okay, we've done these before. And then over here, here's your domain, which are your x's. And here's your range, which are your y's. Okay, and again, this is something that we've done in lesson 2, your domain and your range. All right, so let's look at your got it problem. Choose 4 values for x to complete the function table for the function f of x equals x minus 7. Then state your domain and range. To make things easier so we can all check our work, let's do this. I'm going to choose your values for you, okay, so that we all have the same ones. So let's choose these, negative 1, 0, 1, and 2. Here, and I'll even pull this down to help you get your table going. So go ahead and make your table and complete it. Go ahead and pause the video and then we'll check it when you're done. Alright, so if we plug negative 1 in, you should have negative 1 minus 7, which is a negative 8. 0 minus 7 is negative 7. 1 minus 7 is negative 6. And 2 minus 7 is negative 5. So your table should look like this. Okay? Then your domain and range. Your domain are your x values. Your ranges are your y's. Okay? Alright, let's look at another example here. There are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, P of j, is a function of the number of jars of peanut butter, which is j. Okay? So if you want to look at this as your y, remember this is the same thing as y. Identify the independent and dependent variables. So if we were looking, which one depends on which? Okay. If you have a certain number of jars, does your peanuts depend on the number of jars? Let's take a look. Since the total number of peanuts depends on the number of jars, the number of peanuts is your dependent variable. That's going to be along your y-axis. The jars are your independent variable. That's going to be your x-axis. Okay? The number of peanuts depends on the number of jars that you have. Okay? Okay, number 4. What values of the domain and range make sense for this situation? So they want to know what range and what domain, what x values and what y values make sense. Only whole numbers make sense for the domain because you cannot buy a fraction of a jar. So if you're looking at your x's, which are your number of jars, you can't buy half of a jar or 3/4 of a jar. So only whole numbers make sense for your x's or your domain. The range value depends on the domain values. So the range will be multiples of 770. So for one jar, it would be 770. For 2 jars, you would take 770 times 2. Okay, so that would be your range. And again, those would be whole numbers as well. You're not going to have a negative number of peanuts. That doesn't make sense. Okay? And let's look at number 5. Write a function to represent the total number of peanuts. Then determine the number of peanuts in 7 jars of peanut butter. Well, let's take a look at what they give us. Okay, we know the number of peanuts, which is P of J, equals 770 times the number of jars. There's 770 peanuts in one jar. So there's your function. There's your equation written in function notation. To find the number of peanuts in 7 jars of peanut butter, let's substitute 7 for J. Okay, so 770 times 7 is 5,390 peanuts. Okay. All right. So the last got it problem here is just like the problem we just did. Use that as an example. A scrapbooking store is selling rubber stamps for $4.95 each. The total sales, F of n, is a function of the number of rubber stamps, n, sold. So pause the video, try and do D, E, and F, and then we'll check them. All right, we have to identify the independent and dependent variables. So think to yourself, what would go along the x-axis and what would go along the y-axis? What depends on what? Okay. Well, the number of stamps is the independent variable. That's what's going to go along the x-axis. And your total cost or your total sales is your dependent. The number, your sales, your total sales depends on the number of stamps sold. Okay. What values of the domain and range make sense for this situation? And explain. Only whole numbers make sense for the domain because you can't buy half of a stamp or a fraction of a stamp. You can only buy whole stamps, so whole numbers. And the range is going to be a multiple of 495. Okay, so 1 times 495 or 2 times 495, those are multiples. And again, you're not going to have any negative values. It doesn't make sense to have negative number of stamps or negative number of dollars in this situation. And write a function to represent this. F of n equals 4.95n. Okay, n is the number of stamps. So if we plug 5 in, 495 times 5, you're going to get 2475. Okay. Your homework then is to try the guided practice problems at the end of this section here, and we will check them first thing tomorrow.